Yesterday, we are talking about modulation AM and FM. So today we are to talk about digital modulation ASK, FSK, and PSK. So what are the digital modulation techniques? There are mainly three types of analog modulation, which are amplitude modulation, frequency modulation, and phase modulation. Here, the amplitude, frequency, and phase of carrier wave change with respect to amplitude of message signal. Whereas in digital modulation, a process called shift keying is used. Shift keying means that the amplitude, frequency, or phase of carrier wave is shift between two or more discrete values rather than varying continue like analog modulation. Binary data require two discrete levels of amplitude, frequency, or phase modulation called as binary shift keying. A group of bits can be clubbed together to form array shift keying. So today we are talk about these three main digital modulation technique. First one is amplitude shift keying, second frequency shift keying, and third is phase shift keying. So before we are going to go to the main point, so we just review the amplitude, frequency, and phase. So here we have the wave higher point. Higher point we call peak, and lower point we call trough. And the vertical distance between peak and wave central axis is amplitude. So what is the frequency? Frequency is a fundamental concept in physics and engineering, particularly in a context of wave and oscillation. Frequency refers to the number of cycles or oscillation of predict signal that occur per unit of time. It typically measured in hertz, where 1 hertz is equal to 1 cycle per second. If a signal completes an n cycle in t time, then frequency f given by f equal to n multiplied by t. So first specific the location of point which wave cycle. The location on the wave can be specified as angle, yeah, in either radian or degree. This can be visualized with a rotation in cycle and spot tracking wave as time goes. So here 9 degree, and here they'll form like here, and if we're going to here, and we'll move to here, also like this. So now we're going to the first point of the three main topic is amplitude shift keying. Carrier wave used to send digital signal, and as you know, ASK is a modulation method where digital signal change the amplitude of carrier wave. In ASK, the amplitude of carrier signal varies in accordance with the digital data. the carrier frequency and phase remain constant. Binary PSK represent the binary data using two different amplitude of the carrier wave. Logic 1 might be represented by the higher amplitude, and logic 0 might be represented by the low amplitude or zero amplitude. If the digital signal value is 1, then the carrier wave amplitude remains the same. And when the digital signal value is 0, the amplitude of carrier wave is much weaker. Yeah, you can see from the picture. Yeah. So we go to the second point. If we can see shift keying. Frequency shift keying is the digital modulation technique in which frequency of carrier wave change with the digital signal. In FSK, the frequency of carrying signal is varied according to the digital data. The carrier amplitude and phase remain constant. In binary, or we call BSK, BFSK represent binary data using two different frequency. Logic 1 might be represented by the higher frequency, and logic 0 might be represented by low frequency. When digital binary is 1, the frequency of carrier wave is higher binary. When binary value is 0, the frequency of carrier would become lower. Yeah. Okay, go to point number 3 is phase shift keying. So PSK is a digital modulation process which is transmit data by changing the phase of constant frequency of carrier wave. We can see the frequency amplitude of carrier wave remain the same. Only change is phase specifically. Phase change at the point where the binary value 1 change to binary 0, or where 0 change to 1. In PSK, the phase of carrier signal is varying according to the digital data. The carrier amplitude and frequency remain constant. Binary PSK, BPSK represent binary data using two different phases. Logic 1 might be represented by phase shift of 0 degree, and logic 0 might be represented by phase shift 180 degree. You can see. So in summary, each digital modulation technique has strength and weakness, making them suitable for different applications. Like ASK is simple and bandwidth efficient for low data rate, but it highly susceptible to the noise. FSK offer better noise immunity at a cost of higher bandwidth and more complex receiver. PSK provide efficient bandwidth usage and higher data rate with increased complexity in a receiver design. So this choice of modulation technique depends on the specific specific requirement of a data communication system, such as data rate, bandwidth, availability, and noise environment. Okay, so that's all for my slide today. Thank you.